All right, let's jump right into something kinda wild. We're gonna talk about a place where neuroscience and computer science are starting to look, well, a lot alike. We're gonna explore this really strange idea. What if the future of AI depends on teaching it something we do every single night? What if AI needs to learn how to sleep?
I know. It sounds like something straight out of a sci-fi movie, right? But believe it or not, this question is becoming one of the most important ones in the whole field of AI. And to really get why, we need to rewind the clock a bit, back to the very first time a machine really imagined something.
Okay, so where did this whole crazy idea even start? Well, our story doesn't begin with the chatbots we're all using today. Nope, it starts with images, and with the first time we ever got a real glimpse into what a neural network was actually, well, thinking.
Back in 2015, there was this program from Google called Deep Dream, and it started spitting out these absolutely incredible, totally surreal images. So here's how it worked. The network was trained to recognize things, like dogs or buildings. But then the engineers did something clever. They flipped the process. They asked it not to recognize things, but to enhance whatever patterns it thought it saw. And wow, it started finding patterns everywhere, creating these wild, psychedelic, dreamlike visuals.
And this quote from Mike Tyka, who was one of the artists working with it, just nails it. He said it's like cloud watching. You know how you stare at a cloud and suddenly see a dragon or a face? That's exactly what the AI was doing. It wasn't making stuff up out of thin air. It was just over-interpreting. It was taking random shapes and cranking up the volume on any pattern it had ever learned, so the tiniest little curve could suddenly morph into a dog's face.
Now, this is super important. We have to be really clear here. This kind of dreaming is completely different from what we now call AI hallucinations. Deep Dream, that was all about a creative riff on an existing picture. But the hallucinations you see from today's language models, that's them confidently just making stuff up. See, their whole job is to predict the next word, not to know what's true. So one is like seeing a puppy in the clouds. The other is like a chatbot inventing a legal precedent that never existed. Big difference.
And that actually brings us to the heart of the matter. The reason we're even having this conversation about AI and sleep, well, it's not just some cool futuristic thought experiment. It's because the AI models we rely on today are facing a really fundamental crisis.
To put it simply, the biggest problem AI has is that it never, ever sleeps. Think about it. These models are built to be on 24/7, always on, always learning, always working. And just like with us, being awake forever, well, it has some pretty severe consequences. So this always-on state leads to three massive problems. First, something called catastrophic forgetting. It's exactly what it sounds like. Imagine you spend a year learning Spanish, and in the process, you completely forget how to speak English. That's what happens. Then there's proactive interference. This is where old information actually starts to mess with and corrupt new information. And finally, you get synaptic saturation. Basically, the AI's brain just gets full. It can't integrate anything new. Kind of like how when you're exhausted, you can't seem to learn or remember a single thing.
Okay, so if the problem is basically burnout, no rest, no time to organize its thoughts, then the solution has to involve reorganizing all that knowledge, right? But where does an AI even keep its knowledge? To answer that, we have to take a look inside the machine's mind.
This inner world has a name. It's called latent space. Now this can get a little abstract, so hang with me. The best way to think about it is like a giant multidimensional map of every single idea the AI knows. On this map, concepts aren't words, they're coordinates, they're points in space. And the cool part is, ideas that are similar, like king and queen, are really close together. Ideas that are different are far apart. It's literally the AI's internal atlas of meaning.
And this quote, this one really makes it all click. Meaning becomes geometry, knowledge becomes topology, and reasoning becomes movement. So for an AI, reasoning isn't about logic like we think of it. It's about literally moving from one point on that map to another. It's about drawing a line, a trajectory, through this huge geometric landscape of ideas. Wild, right?
And here's the thing. This map of meaning is way too big for any human to explore alone. This is where the whole idea of a human-AI team-up becomes so critical. As you can see here, our human intuition can kind of set the compass, point in the right direction. But the AI provides the reach. It can explore all these conceptual paths at lightning speed. But for any of this to work, the AI's map has to be stable. It has to be organized. And that's exactly what the always-on problem messes up. You can't be co-navigators if your partner's map is constantly glitching out and falling apart.
All right, so let's recap. We've got the problem, the state of perpetual wakefulness. We know where the problem lives.
in the AI's latent space, its internal map. So, how do we actually fix it? How do we teach a machine not just to learn, but to actually rest and consolidate what it knows?
Well, believe it or not, researchers are building solutions by looking directly at us, at the human brain. They're developing things like this wake-sleep cycle. It's a 3-step process. First, you have the wake phase. Pretty straightforward. The AI is out there learning new stuff just like us during the day. Then comes the NRM sleep phase. Here, it's like it's replaying its memories, locking in the important stuff. And finally, you get the REM sleep phase, the dreaming part. The AI simulates new experiences, getting itself ready for things it hasn't even seen yet. It's all about making it smarter and more adaptable.
Of course, this opens up a massive philosophical can of worms, doesn't it? Is the AI actually dreaming, or is it just a really good simulation? A lot of philosophers would argue that without a body, without emotions, without a real-life story, it can't be real. They talk about autopoiesis, this idea that real consciousness has to come from a living thing that is self-creating and motivated. But, from a practical point of view, maybe it doesn't matter if the dream is real for the AI. What matters is what a stable, well-rested, dreaming AI can do for us.
And that leads to this really profound shift in how we should think about AI. The future here isn't a person using a tool, it's a partnership. It's us becoming co-navigators, exploring this enormous landscape of meaning together. A landscape that's growing way too fast for us to map it out by ourselves. And let's be honest, a partner that can rest, that can learn properly, and that can keep its own map in order, that's a much, much better partner to have.
So, when you think about it, the real paradox here is that as we build these incredibly powerful thinking machines, the next great leap forward might not be about making them smarter. It might be about making them sleepier. To make them more intelligent and more stable, we first have to teach them how to rest. So maybe the next big challenge isn't teaching machines to think. It's teaching them how to truly wake up.